Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound shown is 3-phenylglutaric anhydride. It consists of a benzene ring bearing a CH2 group at one end, connected to a CH center, which bears another CH2 group. These two CH2 groups each carry a carbonyl that together form a cyclic, 5-membered anhydride ring, pH CH2CH, CH2C is equal to O-OC is equal to O, i.e., the anhydride ring contains C is equal to O-OC is equal to O, CH2CH, CH2pH, closing into a 5-membered anhydride. Moving on to the next step. AlCl3 activates one of the anhydride carbonyls to generate an acylium ion, or acyl-AlCl3 complex. Intramolecular Friedel-Crafts acylation occurs when the acylium attacks the pendant benzene ring. Moving on to the next step. Determine which carbonyl reacts and ring size formed. In 3-phenylglutaric anhydride, the two carbonyls are at C1 and C5 of the glutaric chain, with the phenyl on C3. The CH2 adjacent to the phenyl ring, benzylic CH2, connects to one carbonyl. For intramolecular acylation onto the ortho position of the benzene ring. Attack by the carbonyl closer to the benzene, through the benzylic CH2, i.e., 2 carbons away from the ring, would form a 6-membered transition state and produce a 6-membered carbocyclic ring fused to benzene, giving a tetralone, beta-tetralone type, i.e., 2-tetralone or 1-tetralone skeleton. Attack by the distal carbonyl would require a longer chain and form a less favorable ring. And for the final step, the intramolecular acylation via the benzylic carbon, PHCH2 attacking the ring with the acylium derived from the adjacent carbonyl, forms a 6-membered ring fused to the benzene ring, producing a 1-tetralone framework. The remaining CH-CO2H, after ring closure, the other carboxylate end becomes a free carboxylic acid upon hydrolysis. Workup of the mixed anhydride oxygen is at C3 of the cyclohexanone ring, beta to the ketone carbonyl, giving 3-carboxy, 1-tetralone. Why not a 5-membered ring? Options C. The formation of a 5-membered ring would require direct attack through only one carbon, which is geometrically strained and disfavored compared to the 6-membered transition state. Friedel-Crafts cyclizations strongly prefer 6-membered ring formation, Baldwin's rules and thermodynamic preference. In option A, CO2H is alpha C2 to the ketone. In option B, CO2H is at C3 beta. Given the connectivity of 3-phenylglutaric anhydride, the acylium forms at C1 attacks the ring closure uses C1, C2, benzylic, ring bond, and the remaining chain CH, CO2H ends up at C3, 1 carbon away from the benzylic position, which is C2 in the new ring, hence CO2H at C3. This matches option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.